Greetings, members, one and all of the Salivation Nation. This device could cause silver demand to explode. Let's explore. What is this strange-looking device here? Well, as was shared with me by a member of the community, this is an article from Clean Technica. 200 years later, a silver zinc energy storage is finally having its moment. There's some promise here with this technology here. The race for the next big thing in energy storage suddenly got a lot smaller, slimmer, lighter, stretchier, and twistier. Now that researchers have solved some kinks in the silver zinc technology. That's very exciting to hear. Those are things we all like in our devices, to be portable, small, even flexible. The new battery is not quite ready to slide into electric vehicles, but it does pave the way for a new generation of lighter, more efficient electronic gear and better prospects for recycling as well. According to NASA, the silver-zinc or energy storage combo first came on the scene about 200 years ago. Wow. Give or take a few, technology obstacles still linger, but the allure of high-energy density, compact size, and low weight provide ample motivation for researchers to keep powering through the problems. The silver-zinc combo offers more energy per ounce than any other battery couple. NASA enthusiast enthused in a 2016 technology recap, while noting that early versions of the battery were dogged by significant issues. And the biggest challenge for silver zinc batteries was that their electrodes, the cell's negative and positive electrical conductors, were soluble and deteriorated quickly. NASA explains, the answer to this challenge, developed first in the late 1920s by Professor Henry Andre, and then advanced by the U.S. military in World War II, was a membrane to separate the two electrodes. That same 100-year-old technology is still used in some applications by the Department of Defense, including submarines and torpedoes. However, that applies only to disposable batteries. The electrode problem still persisted in relation to rechargeable energy storage devices, meaning that performance would fall off a cliff after just a few charging cycles. And then we had a breakthrough. For NASA purposes, the silver zinc energy storage approach also fell short because performance worsened even more if the battery was thermally sterilized, which it had to be in order to prevent the off chance of, a lethal microbe making its way around the solar system. Fast forward from 1920s to 1972, when a public-private partnership between NASA and the Douglas Aircraft Company yielded a rechargeable version that could hold up under heat sterilization for up to 500 charging cycles. That's close, but no cigar. In the 1970s, a nickel-cadmium energy storage platform commonly used in space applications could last for 10,000 cycles. But if you're wondering why NASA didn't just stick with nickel-cadmium, well, did you already forget the thing about more energy per ounce? As described by NASA, the silver-zinc combo was a third the size of the nickel-cadmium counterpart, and weighed a lot less too. So now, it really is a breakthrough. According to what the article continues, the size and weight savings provided enough interest to keep NASA plowing away at the research and development end after the 70s, but a real breakthrough proved elusive, at least for space applications. The charging cycle numbers improved, but the best performance only occurred if the battery was charged at lower levels. NASA did see some potential for silver-nickel energy storage to push lithium-ion technology aside in commercial areas that require pint-sized energy storage devices, like hearing aids, for example. So NASA says lithium-ion batteries are prone to a phenomenon known as thermal runaway, which in a rare and disastrous cases causes them to catch fire. We've actually all heard and seen or experienced that. This is not a possibility with silver zinc batteries, which uses a water-based chemistry. Lithium-ion batteries also require more packaging and other components that take up larger percentage of their space the smaller they get, so it's less efficient technology for smaller spaces. In the 90s, a company called Z-Power adopted NASA's chemistry and bumped it up a notch. The company has improved all four active components of the battery, the two electrodes, the electrolyte, and the separators, earning some 100 new patents. Wow. The batteries can now survive up to 1,000 discharge cycles without losing significant capacity, and enthused NASA. So, what does this mean for us? If you're wondering whatever happened to Z-Power, it's still here, and the company has been partnering up with the University of California, Davis on the design of a new flexible, rechargeable silver oxide zinc battery that has 5 to 10 times more energy density than the best ones available today. It's a pretty big movement, plus with the portability. The battery is also easier to manufacture. While most flexible batteries need to be manufactured in sterile conditions, under vacuum, this one can be screen printed in normal lab conditions. The device can be used in flexible, stretchable electronics for wearables as well as soft robotics, explains UC Davis. By easier to manufacture, they mean the device can be screen printed as an ink in a normal lab environment. Aside from preparing the inks, the printing takes a matter of seconds, and the battery is dry and ready to use in a matter of minutes. Now that is all the best that you can expect. That's pretty amazing. The research team also notes that a high-speed roll-to-roll printing process could do the trick too. If you caught that thing about oxide, that's key to the improvement in energy density. Other flexible silver zinc batteries are available in the market today, but they use an Ag2O silver oxide zinc combo. The UC Davis teams went from a silver oxide zinc combo, which is a bit of a challenge considering that AgO is difficult to work with. AgO is traditionally considered unstable, but Z-Power's AgO cathode material relies on proprietary lead oxide coating to improve AgO's electrochemical stability and conductivity. UC Davis explained, as an added benefit, the AgO zinc chemistry is responsible for the battery's low impedance. So there is a research paper, a white paper posted on that. We won't bore you with all that. But basically, this is looking good for the future. So far, the only platform the new platform was performed without any significant loss of capacity for 80 charging cycles while being subjected to twisting and bending. A battery that twists and bends. Wrap that around your brain, literally. That again brings up the question of why not stick with tried and true lithium-ion energy storage, but consider the size angle and all the pieces fall into place. Lithium-ion energy storage requires safety procedures and other engineering add-ons that contribute bulk. That's not particularly a problem for larger batteries, but all those extras become an obstacle for miniaturization. The research team is already working on improvements that cut cost and charge faster, with an eye on new devices that take advantage of the new 5G wireless technology, as well as markets in the small soft robotics field. The flexibility angle opens up the potential for a new generation of miniaturized soft robots, provides engineers with more design leeway, the idea of being to tailor the battery to fit the use, rather than having to figure out how to design a robot without a standard battery. By small, they mean really small. There was an article in Nature that reviews the potential of clinical uses in soft robotics, talks about the formidable obstacles that lie ahead. Untethered small robots have a unique capability to non-invasively access and navigate in difficult-to-reach narrow areas inside our body and to perform therapeutic and diagnostic operations. It's nanotechnology, essentially, and they can eliminate the need for an invasive procedure. Recently, the design of any tiny soft-body robots has brought the clinical translation of miniature robots within reach. These robots are physically intelligent and do not damage tissues owing to their size and soft nature. Moreover, their shape can be actively or passively programmed, which enables them to adapt to their surroundings and endows them with a large number of degrees of freedom. It's pretty neat, and silver is involved in this as well. And, you think about that kind of technology to help heal, it can also be programmed to destroy and kill people, probably, my guess, without them knowing. The healthcare field has been playing a whack-a-mole with its carbon footprint, and the COVID-19 outbreak hasn't helped any. New generation of low-impact diagnostic tools would help move things along in the right direction. So all this to say, if there's promise with this thing, sounds like they still have a little bit of kinks to work out with it, but this could be really essentially revolutionary, for sure. It sounds like they're very close to getting there. And then what does that mean? Well, demand for silver and photovoltaics is already a game changer, but this could take it to the next level. What does that mean for the price of silver? That means the price of silver, I think, will go up with things like this that are going to be so inclusive in our electronic devices, even more so than what solar is. We'll see how it plays out, and we'll certainly see how this could potentially benefit the world and people, but also how if silver supply can keep up with demand, which means it could potentially have an effect on the price. But that is the key question. Will supply meet up with the demand? It very well could. I want to keep that in the back of your head there, that silver is a vast majority of silver that's mined is a byproduct of other metals. And that being the case, they could find more, they could do, especially with these other metals that will be involved as well for other things. They will find it and could revive the primary silver mining as well that's out there. And so that is the certainly the part of this that I think is something to consider. That people don't get their hopes up too much that there's going to be a big silver price boom coming in the horizon. Demand very well could be met by the supply, but you never know. But it's exciting anyway, just for the benefit that silver provides in a myriad of different applications. In this case, for battery storage, that could have even benefit our health potentially. So there you have it. Thanks again for the anonymous person who sent this along to me. I'd like to extend a multitude of gratitude to you all for taking the time to watch, and encourage you to please rate, share, comment, and subscribe.